Hello, good morning, everyone. I'm Yahya Alvar, Head of Business Development at UKBIC. Thank you for your time joining this webinar this morning. We have set up a list of webinars to discuss and explain about UKBIC capabilities and new capabilities that we're installing in our facility and how our customers, they can get benefit of those new capabilities to reduce their product development life cycle and go to market much faster with optimized product and optimized manufacturing processes. Let me share my screen and I'll explain about what we're gonna do today and what topics that we're gonna cover today. So today we're gonna discuss about how do we actually bridge the gap from R&D to mass production and the importance of the battery manufacturing scale up during this process. If I can click the next slide, yeah, that is better. So please ask your questions by using Q&A function on Teams. We will try to get through as many questions as possible towards end of the presentation. We try to answer all questions. If there are questions about detail of technical related about process, related about the product, then we can actually take those questions out and then come back to you with proper responses later on. If you need to contact UKBIC after this webinar, please use sales@ukbic.co.uk or info@ukbic.co.uk. If you are a supplier and would like to actually contact us and discuss about supplying material or machine or anything to UKBIC, please use suppliers@ukbic.co.uk. And a copy of these slides and a recording of the presentation will be available via UKBIC website from Monday, 18th of November. Let's go on to the next one. So, bridging the gap from R&D to mass production at UKBIC. This is the first topic that we're gonna cover today. For those of you who doesn't know about UKBIC, we are a part of Faraday Battery Challenge, which has got the responsibility to develop the battery ecosystem in the UK, covering research, development, scale up, and industrialization. We are towards the end of this development run, and our facility is a giga-scale facility supporting customers around higher TRLs and higher MRLs. But we will explain how do we actually supporting customers to bridge the gap. We are based in Coventry. For your information, this is the latest photo of the facility, 20,000 square meter facility based in South Coventry, next to Coventry Airport. Very briefly, what do we have? We have two separate electrode manufacturing lines, one for anode, one for a cathode. We have got wet manufacturing process. We're using solvents. We're using DI water on the anode side and NMP on the cathode side, starting from mixing the powders into coating, drying, and then moving into calendering. We do have also cell assembly. We have got two lines, one pouch line, one cylindrical cells, 21700. We do have fully automated manufacturing and cell assembly process in our facility. We also offer formation, aging, and testing. And we have got also module and pack build facility, including end-of-line testing capabilities. The facility is an open facility for all organizations. They want to scale up their battery technologies in the UK. And it is not just limited about the product. It is about the materials. It is about the manufacturing processes, and anything about battery. As you see, we are a one-stop shop from powder to pack, and we can support different organizations from different part of the journey because the facility is a modular facility. As I said before, we have got giga-scale equipment to de-risk the commercial investment at pre-revenue stage, and we're using the facility for purely R&D purposes. We also open to low volume production if the product is mature enough and we can actually support the product in our line. The most important item in this slide, to my opinion, is about the IP. We don't want to actually maintain or retain any ownership of the IP. When customer comes to us, they have got their own background IP. Any foreground IP created in our facility throughout the development runs is also belonging to the customer. At the end of the campaign, we will deliver all the information, all the data, and we can also support data analytics or some consultancy services to make the new generation of the cell design or improve the electrode design or cell capacity or cell life for different customers. We also delivering trainings. We also delivering let's say different sort of skill development around battery manufacturing processes. These are the two types of the cells that we produce. As I mentioned, 21700 cylindrical cells, and the pouch cell that we produce in our facility is 300 by 100 pouch cells, and the tabs are sitting on the opposite side of the cell. We are at ton scale facility at the moment, and we are here to bridge the gap from R&D, from lab level, from university scale development activities. Many customers, they do develop their product in a lab environment at gram level, but scaling up from lab into a giga scale volume production is a journey, is a challenging journey, and need lots of capex and lots of apex and lots of material to be used to develop the right product for the right application. Currently, we supporting customers that sitting around TRL maybe 678, maybe MRL 678. But we have realized in the last couple of years that most of our customers, they sitting at much lower TRLs and much lower MRLs, and they need support. There is a little gap between where we are and where our customers are. For that reason, now with support from Faraday Battery Challenge, we actually installing a new flexible pilot line, which will address the gap between R&D and our current scale. We installing a new flexible pilot line, which I explain a bit more in next couple of slides. And that flexible pilot line will help us to cover TRL 4, TRL 5, TRL 6, and is going to be very smooth transition from lab level university scale research and development into giga scale manufacturing in our facility. 74 million pound investment, again approved by Faraday, and now we installed a flexible pilot line. As you see on the screen, the picture is a Mattis coating line, which is going to be part of our flexible pilot line. We're also installing a new battery development lab, which will actually give us more flexibility to cover wide range of measurements, analytical analysis on material composition, slurry, etc., etc. We're also installing 5 different clean and dry rooms. which will be available to be rented out to different customers to use for their own development, and we can actually run the facility together with customer on site and help them to support their product development life cycle to be much faster and go to the market much quicker. Let me explain a little bit more about our new capabilities, starting with flexible pilot line. We have realized in the last couple of years that many of our customers, they cannot afford to give us tons of materials where the product is not optimized, the process is not optimized, and the risk of losing active materials is very high. For that reason, this flexible pilot line will bridge the gap between our existing industrialization scale-up line and also will give us flexibility to do development runs much faster, much quicker. We have got 5 individually controlled environmental zones, zone number 1 to number 5, as you see on the screen. Zone number 1 and 2, we're installing new IREC intensive mixers at around 50 liter. We're installing RO5 machines, and those 2 machines will give us more flexibility to do smaller batches, and we don't need lots of materials. We can start with around 40-50 kilograms of materials and then develop new recipes, new formulations, and improve your or customer formulations and recipes for their anode and cathode. We have got room number 3, which is allocated for coating and drying, and Matisse machine will be installed there. That is a single-sided coating machine, and it will give us more flexibility to coat a couple of 100 meters of electrode very fast and very quick. Then we can use those material, push them into calendaring and slitting, and then use the room number 5, which is a dry lab area, to make some coin cells, multi-layer or single-layer pouch cells, or half anode, half cathode cells, and cycle them for a couple of days to understand the performance of the cell. If there is any need to redo the job, repeat the job, go back to the electrode, go back to the mixing process, optimize the mixing again, and then create another couple of 100 meters of electrodes, then run the second run, third run, fourth run. It will give us more flexibility to do different type of materials, different type of mixing procedures, and benchmark the performance at the final cell level. Clean and dry rooms. We're installing 5 new clean and dry rooms. In total is about 800 square meter. They are flexible sizes for different applications, from 83 square meter to around 245 square meter. And we can actually expand them if required for any specific use. These capabilities, these rooms, will be available from January 2025, and the dew point that we can achieve is about -40-degree dew point, and the cleanliness is ISO 7 clean rooms. These rooms are available for any customers if they want to bring their own machine, and we can make electrode for them, for example. They can use that electrode in one of these rooms, complete their development runs, and then take their machines out of the facility at the end of the product development process. We also installed new battery development lab. This new battery development lab will give us a bit more flexibility to do a bit more characterization, processing, electrochemistry analysis, forensic examinations, and CT scanning. There are 5 different areas that we focused on. You're maybe much more familiar than me about characterization, different analytical methods that we actually using to understand about the materials. And on slurry characterization, for example, now we're going to do everything in-house. Electrochemistry analysis by using coin cells, multi-layer or single-layer pouch cells, for example, or cylindrical cells, for example. Forensic examinations, we have received lots of requests from different customers about doing cell teardown activities. Now we have installed that capability. We have got a specialized glove box which is equipped with thermal and optical cameras. We can take photos, we can record the entire end-to-end cell teardown process, and we can also train your engineers, your technicians, to understand the process and understand how it works. CT scanning is also another capability that we have got, and we can do CT scanning as part of the non-destructive failure analysis in our facility. The other one is about cell cyclers. We installed 2 new cell cycling capabilities, 192 cylindrical cell channels that we have got, and also 96 pouch cells we have got. This capability is up and running right now. We have delivered a few customer programs, and if you need your cells to be cycled, please let us know, get in touch, and then we can help you to either just to cycle it or even can help you to develop the cycling protocols. And the next one is about the training. Obviously, getting access to the right skill set is critical in this industry. Training is an important part of this bridging the gap in the UK market. We offer different sort of trainings. We offer introduction trainings into battery manufacturing processes, into module and pack build, for example, cell assembly, formation aging testing. We do offer bespoke trainings, we do offer sustainability trainings, and we do offer trainings about hazardous material and clean and dry rooms. A couple of those trainings are available via our website. If you are interested, you can check our website and then enroll to those trainings. The next part of today's conversation is going to focus on the importance of the battery manufacturing scale-up and why this scale-up is important. I'm going to take you through a couple of lessons learned. Obviously, you may appreciate that we couldn't actually cover everything, and there are lots of case studies. The case studies that you're going to see today, they're just hand-picked case studies, and they are from different customer programs and the challenges that we had, the lessons we learned, how to fix those challenges, and then that is the know-how created in-house at UKBIC, and we will use that know-how to deliver the new customer programs much quicker and with highest possible quality. So you know about these giga factories around the world. There are tons of these gigafactories. There are different formats of this slide. I didn't want to actually spend too much time on this one. There are lots of gigafactories talking about the blocks of 10 gigawatt hour facilities, talking about a couple of 100 millions of cylindrical cells. And they're talking about different things, but the problem here is that if they don't follow the right scale-up process, they cannot actually be successful. That is the critical message. The scale-up is a journey, is not just one-time run. We can't address all the questions after doing the programs or any programs for just only once. This journey is challenging. Lots of parameters needs to be updated at product level. Lots of parameters needs to be updated at manufacturing level. What we have learned from different programs that we delivered in the last 4 years is that it's better to actually have a clear plan. Start with product modeling, simulation, e-chem analysis. These are all the capabilities that we offer in our facility. It is about the knowledge transfer. It is about actually interacting with customer to understand what you want to do, how we can help you. Start with simulation, which is much more convenient way to start. Then moving into the first prototype scale, which is about manufacturing maybe 1,000 cylindrical cells, manufacturing maybe 100 to 200 pouch cells. And we need to repeat this process a few times, build one, build two, build three. We need just to create a baseline and then improve every single iterations of the runs to see how the product will be improved. The next run is about the pilot run, roughly about 10,000 cylindrical cells, maybe about 1,000 pouch cells. During this process, we will optimize the shadowing, process yield, and control plans. Again, this is another important step of this journey. And the last part is about manufacturing at industrial scale, which roughly talking about 100,000 cylindrical cells, maybe 20,000 pouch cells. We need just to retune the manufacturing processes, minimize the controls, and increase the throughput, increase the yield, increase the speed. And then all the documentation, everything created throughout these processes will belonging to the customer. They know what manufacturing process they need to buy. They know what material they need to invest on, and what is the best manufacturing process for their specific applications, for their specific design. Let me just a little bit speed up. You know the importance of the vertical integration on the supply chain, from materials into the recycling. This is something that is almost everywhere, and we need just to address all these steps. I'm just going to actually focus on one comment from APC, that they estimated about £12 billion opportunities in the UK for UK players to get involved in any part of these steps. And at UKBIC, we can support from early stage into around modular and pack build. So let's focus on some lessons that we have learned, and this is the real case studies that I'm going to share about importance of the battery manufacturing scale up. The first one is about the mixing. The challenge here is that it is proven that active material behavior are different from smaller scale mixes into larger scale mixes. Slurry rheology needs to be fall into a range to match the equipment for coating process, for example. Mixing recipe, temperature, motor speed, shear rate, timing, and all those sort of things will influence the slurry rheology. We need just to actually make sure that we are addressing these things. Let me just move to the next one. On this slide, on this screen, the orange curve on the right-hand side of the screen is the initial cathode slurry curve when the customer came to us. That was the viscosity versus shear rate. And as you see on the screen, we couldn't actually coat that slurry. It was not within the acceptable range for the coating machine. Then we had to do different sort of activities to develop the recipe and improve the mixing procedure for that specific customer. And the gray line is the modified cathode slurry that we have done in our facility, which was absolutely fantastic and no issue on coating. These are the type of the activities. I don't want to read the slide. I'm just telling you that where customer came to us, where they were, and what we have done to them to improve their mixing recipe and slurry rheology. The next one is about coating. The real challenge is about the mass-free zones and bleeding into the mass-free zones. Thank you very much for reminding me about time, Richard. So I'm going to speed up. The challenge here is that mass-free zones are required to weld the tabs, and we cannot have those bleedings into mass-free zones as it is present on the screen. So what we use slot die coating system from door, and we do simultaneous coating on both sides of the foil. We know the lessons that we learned is that tuning at the giga scale or at our machine level is important. We can't actually avoid that. Uh, and it is very expensive. If we don't do the development runs, then fixing those kind of problems later on is going to be really, really expensive. We know we have got the know-how in-house how to deal with these mass-free zone issues and how to optimize the product for different chemistries for LFP, LFMP, sodium ion, NMC 622811, or even higher nickel content materials. The other problem about coating was about streaking, for example, on the screen as you see, or the frequency of the defects that we have seen, for example, let's say bubbles or different sort of problems that we could actually see. The source of these problems on the coating could be different things, could be the viscosity, could be ineffective degassing, for example, or could be the particle size, could be the mixing process itself. So we need to understand the material, we need to understand the particle size, we need to understand what mixing process is the best for type of the material that the customer is using, and then how we can avoid these kind of effects during the coating process later on. On the calendaring side, there are lots of considerations to increase the energy density, for example, achieving different porosities, different thicknesses, and to avoid any delamination during calendaring processes. These are the important things that we need to do. But I've just decided to choose one interesting example here, which is about asymmetric anode electrode calendaring. When we're talking about asymmetric anode electrode, we're talking about unaligned coating patterns between side A and side B, as it is on the screen top right hand corner. And we need a bit larger mass-free zone to actually weld the tab. The challenge here is about the calendaring. How do we want to calendar those mass-free zones on the side B? So a part of the foil is coated on double side, and a part of the foil is just just coated on one single side. And then we have got also mass-free zones between different patches. The lesson that we learned was about how do we actually need to set up our the calendaring machine. And understanding about different chemistries and how the material behave in this kind of situations is really, really important. How to calendar asymmetric electrode to achieve the higher densities is something that we can actually share the detailed information if you are interested, but this is very interesting topic. And for us to make sure that we do this in the right way and avoiding damaging our calendaring machine is also critical. The next challenge here on the pouch cell side, we do continuous coating, for example, but calendaring, it's gonna create some sort of creasing and embossing on the foil side, as it is clear on the screen. There are different ways that we can actually use to avoid that. But the problem here is about actually compressing hard materials like NMC material into a very soft aluminum foil. To avoid this kind of creasing issues or sometimes even embossing issues, We have used different just techniques. Just to let you know, we have used 150-degree induction heating. Obviously, it cannot eliminate all the embossing issues, but it will improve significantly. We also have used wrap angle to actually solve the problem, which actually showed a bit more promising results. And we had no adverse effect on properties of the coating at around 150 degrees when we used IR heating. I'm just gonna speed again, Richard. Thanks for reminding me. Slitting challenges, achieving the right edge quality during the slitting is important. To achieve that right high quality edge, we need to think about different sort of things, like, for example, blade geometry, tension settings, blade overlaps and thrust and speed. And also we need just to think about electrode input and exit angles to improve the edge quality for different materials. And from one material to another material, all these parameters needs to be optimized in slitting process. The last one is about elongation on cathode electrode after calendering. Cathode electrodes will be elongated after calendering process, and that is something that it has to be considered from the beginning of the cell design. If that elongation, if anybody actually cannot, let's say, accommodate that elongation in their initial design, then they will see plating around the top tab after first formation, which will actually cause a cell to be failed. So we know that elongation cannot be eliminated. This is the most important lesson to be shared. And elongation needs to be considered in the electrode, especially on the cathode side, and also cell manufacturing process. And this is about the density of electrode, web tension setting, coating geometry, etc., etc. So that was it for today. The next two slides is about the next two webinars. The second webinar that we have planned is on 5th of December. And the second webinar will focus on introducing the UKBIC battery development laboratory. I'm going to be your host for the next one, and our CTO, Richard Licane, will be the main presenter. He will explain about our battery development laboratory, new capabilities, new machines. And then the next webinar, which is planned on 16th of January, is about flexible pilot line, the benefit of using flexible pilot line to reduce product development life cycle. Again, I'm going to be your host, and Richard Licane, again, our CTO, will be the main presenter. And for that one, we also have got a guest speaker from WMG, University of Warwick, and the name will be confirmed later on. Last but not least, thank you very much for your time. Thanks for listening. And now I'm going to open the floor for questions. If you have got any further questions, please do get in touch with us, either via our sales or info email box, or suppliers, or if you are interested to actually have a direct conversation with myself, please just use my email as it is on the screen. Thank you. Richard, can we just open up for the questions? Could you please let me know what the questions are?
There's no questions at the moment.
Okay.
Which have come in. Actually, we've had one question from William Reynolds, and he asks, have you had any clients go from TRL4 to TRL9?
That is a very good question. The answer is a bit tricky because depends on the definition of the TRL4 to TRL9. We had customers that they have done multiple builds with us, build 1 to build 5, build 6, for example, and there were different steps in each of the builds. But what I can actually tell is that we had customers that they came to us at around TRL4, as you highlighted. And when they left the facility, they were around TRL7, not TRL9.
Thank you. What is the probable cause of the slurry gelation?
Yes, slurry gelling actually have got different sort of sources. It depends on the material, depends on the mixing recipe, depends on the solid content, depends on the mixing recipe itself, and we need just to study different materials to understand how slowly they will gel. We have got, we had a customer on site, NMC 811 chemistry, and for their even material supplier is also critical here. For their material, we followed their mixing process, and slowly was not stable overnight and start gelling from the day before, even after degassing process. Sometimes also slowly gelling depends on the degassing process. Sometimes an hour is enough, sometimes 2 hours required, sometimes a bit longer is required. But there are different parameters involved, and we cannot actually say one set of parameters will be applicable to other electrochemistry or other materials. In fact, we also had another NMC customer, NMC 811 customer on site with a different mixing recipe, different material from different supplier. We mixed and we kept the slurry under agitation for about 4 days, and there was no problem at all, even after 4 days in the slurry rheology. No gelling at all.
A question from Berlin Wilson. When do you expect the battery development laboratory to be up and running?
So our battery development laboratory is now up and running. CT scanning is available, characterization is available. We do some forensic examinations. We have done lots of cell-teardown programs in the past for different customers. The only part which is under let's say installation and commissioning right now is about the dry battery lab, which will give us more capability to make some coin cells and single or multi-layer pouch cells. That facility will be up and running from early January.
William Reynolds just follows up on his question from earlier. And what did going from TRL4 to TRL7 cost the customer? Or how do clients pay for the use of UKBIC?
So, yeah, that is also another good question. I can't tell how much it cost the customer to move from TRL4 to TRL7 because there was lots of activities that we did. But to answer the question how the customer will pay to use the UKBIC facility is simple. It depends on the customer program. If you would like us to start from mixing powders, go through end to end, make electrode, make cells, depending on where you are, where the customer is, and how mature the product is, we can offer different solutions. There is no one meter can fit everything. So we need just to assess what customer wants, what processes, which steps of the processes involved. And the way that we costing customer programs here is very simple. There is no margin markups here. Everything is at cost. We costing the direct time on the line, direct resources, a bit of energy usage, and that is the cost that customer is paying for using the UKBIC facility.
The next question from, apologies for the pronunciation, Marcello Scaleup. What is the UKBIC status on dry coating? Have you had a chance to develop something in this field?
Yes, we have received lots of requests about dry coating. In our new flexible pilot line, we will install a new extrusion mixer, which will help us to do dry mixing. We can also use IRIC intensive machines to do dry mixing. However, we don't have dry coating capability. There are conversations about dry coating capability, and dry coating and calendaring needs to be done back to back. As we speak today, we don't have that capability, but I can't tell you if that capability will be installed later on or we're not going to go for it. I have no idea at the moment.
The next question from someone who refers to himself as MS. What are the steps of good slurry? And the second question, dry mix is crucial.
Yes, dry mix is yes, we can do dry mix, as I mentioned, for developing mixing recipes, for example, for different materials. And what was the first question about the slurry?
What are the steps of good slurry?
So again, when you say good slurry, we're talking about rheology parameters, we're talking about the target solid content, we're talking about the viscosity, we're talking about the slurry stability over a night, or under agitation in a kind of a vacuum chamber for during the degassing process. But again, from one material to another material, depending on the particle size at D50 level, D90 level, depending on the application, wettability, contact angle, there are lots of stuff that needs to be tested, needs to be validated to make sure the slurry is good quality slurry to be used during the coating process.
Okay, there are no further questions.
Okay.
Last chance for final questions.
Yeah, if there is any other final questions, if not, then again, thank you very much for your time. Thanks for listening. All these slides and the recording will be available in our website from 18th of November. Please do get in touch with us if you have got any further questions about any steps of the process. We are very modular facility. We can start from calendaring if you give us coated material, for example. If you give us slurry, because sometimes customers, they saying that mixing recipe is their IP, they don't want to give us the mixing recipe, that's fine. If you give us slurry, we can start from coating process. Or if you give us calendared electrode, for example, we can start from cell assembly. Or if you give us your cell manufactured somewhere else, we can start from formation aging, or we can actually cycle the cells for you and explain about the degradation